Welcome to episode 246 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Burfing, joined by my co-host, Jason Turner. Jason, how you doing today?
I am all right. Rob, how are you doing?
Doing just fine. Getting by. You have any news or announcements you want to share?
Well, I don't know. There's conference changes happening all over the place, but I don't have anything to share specifically at the moment. Maybe next week regarding that stuff. But it does look like I am going to be doing a live stream with Matt on Friday, probably, although that has not been officially announced yet. And it'll probably be about the same time this is going live.
Okay. So
Godbolt, that is.
If you're tuning in on the day this podcast comes out, maybe check Matt and your Twitter feeds and see if you're doing a live stream.
Yeah, we might be doing a YouTube thing there.
Okay, cool.
We teased you Twitter about it last week, so.
What would this live stream be about? What would the topic be?
Well, we haven't decided yet, so I can't tell you.
Okay. Well, at the top of every episode, I'd like to read a piece of feedback. We got this tweet from the Rust and C++ Cardiff user group saying, we had a chance to listen to the story behind Daniela Engert and C++ modules in the CppCast episode not so long ago. Need to catch up with the video. Thanks, Meeting C++ for the reminder. So, her talk, which we kind of mentioned and talked a little bit about when we had Daniela Engert on, is now live.
It is live. Okay, great.
It is live. So if you want to watch modules, the beginner's guide, that is now on YouTube. You can go watch it.
Sounds like something we all need to watch.
Yeah, we definitely all need to learn more about modules. They're coming. Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Billy O'Neill. Billy is a developer and standard library maintainer at Microsoft. He is also often on loan to other teams, such as the Visual C++ infrastructure team, for example, working on the distributed compiler test harness, and most recently, the vcpkg team. Before joining the C++ team, Billy worked on security compliance tooling in the former Trustworthy Computing team. Billy, welcome to the show.
Hi. How's it going?
It's all right here, yeah. How does that work? How do you get loaned out to other teams? Do they have a library card that they have to stamp? What?
So basically I've just, made it known to my bosses that I'm not super picky about what exactly I'm working on. So if you talk to Stefan and ask him to do things that are not standard library related, Stefan is going to be very angry at you. Okay. Relatively speaking. Whereas I'm never going to be the template metaprogramming wizard that Stefan and Casey are. But what I am willing to do is whatever the heck needs to be done right now. So the vcpkg team needs somebody. Wow, that was loud. The vcpkg team needs somebody. Okay, go send Bill to do that. Kind of happens. It's not like it's not it's not unilateral. Like somebody on the vcpkg team can come over and say, "Hey, Bill, I need help with this." It's more like they go to my boss and say, "Can we have Bill for a couple months?" And then
at some point your boss says, "Okay, we're ready for him to come back."
Pretty much.
Which gets you exposure to a lot of different types of projects and different types of programming, that sort of thing.
Even more than just normal standard library shenanigans do. Yes.
I can see that. I mean, some of the most interesting experience I got at work was when a new project would come up and I would volunteer for it. And 9 times out of 10, it was stuff I didn't know anything about, and somehow I convinced them to trust me to try.
Yes.
Very cool. Okay, well, Billy, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking more about the work you've been doing at Microsoft, okay?
All right.
So first one, we kind of have 3 of these conference-related announcements where, because of what's going on in the world right now, the conferences and meeting user groups are moving online. So the first one we have is C++ London. They're going to be doing a live YouTube stream for their future C++ London user groups. They're going to have a Slido site set up, which I'm not familiar with, where you can ask questions and do polls. And they're also going to try to do like a post-presentation video conference where people can just hang out. They even said drinks are optional, so I thought that was pretty neat.
Okay. Yeah.
Yeah. And the other one is Core C++, which we've talked about several times as the conference, but it's also just the Jerusalem area user group, right, Jason?
Well, between Jerusalem and Tel Aviv, yeah, they move back and forth, yeah.
Right. So they're also going to be, doing an online version of their meetup, and I think they're doing theirs on Zoom. And then what was the last one, Jason?
Is C++ on C.
Right.
Is the actual conference is moving online. So this is interesting because Phil says on here that there will be a greatly reduced ticket price, but does not yet say what that means exactly. But he's going to put up, oh no, here it is. We're reducing the ticket price to £150 for the full conference. So 2 full days of conference. I think that's right.
That's interesting. I wonder how well something like that is going to do with, others offering content for free.
I am actually very interested in this as well, both as a business model and, how successful it'll be or not. He does specifically state that he's using the experience that they've already gained from the C++ London meetup for how to handle a project like this. So if you can imagine multiple tracks going at once with the ability to do polls and feedback from your audience and everything, it seems the most promising of what I've seen so far.
Yeah. Well, hopefully it does well.
Yeah.
And speaking of online conferences, Billy, Microsoft actually just put one on last week, right? Were you involved in that at all?
I wasn't directly involved.
Okay.
I got asked to do some reviews of things that were put up, and I got asked to provide some demos and things like this. But that was mostly Mahmood, my boss, doing that on his own.
And that was the pure virtual C++. I think I watched the
Yes.
first 2 hours of that maybe, and it was pretty good.
I checked in once or twice. I didn't stay on for it, yeah.
Well, they did turn each of the talks into separate YouTube videos. So if anybody is interested in modules or vcpkg or standard library stuff and didn't want to stay on a 8-hour live stream.
Right.
And I like the way they handled it with, Sai getting everyone to pre-record the content and then show it live with a Q&A session afterwards. I thought that was a very good way of doing it.
Yeah, I think he drove most of that whole conference effort.
Yeah.
He was he has this thing where he's like, submit 3 talks to CppCon just in case. All 3 get accepted. All 3 get accepted. That's been his MO, I guess.
Yeah. Okay, and then, go ahead.
Before we move on, just also mention, one reason I wanted to discuss that these meetups are online, I called out specifically the C++ London and the Core C++ one, is just the fact that everyone is doing this. So if you keep your eyes open, look at your local meetup, they're probably doing something online. I know my meetup has moved online, partially just because I don't think we could stomach the idea of missing one because we've gotten a 36-month record now, something like that. So our meetup is going to be tomorrow night. It'll be too late for this podcast, but you can find the C++ Denver meetup on meetup.com and join as well if whoever's listening wants to.
It'll be interesting to see how much, online membership differs from your average normal meetup because, anyone can attend if they want to.
Yes.
Yeah.
I have no idea how this is going to play out really ultimately.
Okay. And then the last thing we have is this, blog post, useful tools for checking and fixing C and C++ code. and other languages too. And it's really just a list of different static analyzers and other tools that I thought was a pretty good resource. CppCheck, Coverity, we've talked about most of these before, PVS Studio. I don't think I've seen SonarCloud before. Are you familiar with that one, Jason?
I've had students mention it in classes, but I've not used it myself.
Oh, okay.
I think that's like a big, like do analytics on what tools report on your code base overall. At least that's what it was. I don't know. A few years back when I was in the security team, they were talking about this being the new thing that would replace a whole bunch of internal stuff that we had built.
Is it like an aggregate kind of thing?
Yeah, like show me all of the potentially uninitialized variable used hits in Windows.
Right.
Kind of tool.
I would hate to see that report. I'm sorry. I mean, because it's just such a large code base with such a history, I'm guessing staying on top of that kind of thing is quite difficult, actually.
Yeah, I was, for example, the C++17 guaranteed order evaluation rules actually broke stuff in NT because they were dependent on the particular unspecified order of evaluation that the compiler optimizer had chosen.
Nice.
Yes. So, you know, you change anything, Windows will notice.
That's kind of awesome, actually. So it gives the compiler team a lot to play with when they need to, huh? Or standard library.
Yeah, that's a blessing and a curse. You know, because if you want to see like, will the compiler change you just made build Windows? Well, that even on like a fleet of machines, that's a full day thing.
Right.
So,
huh.
Like you kick that off and you come back the next day and it might have worked.
Can you request, like, I don't know, some sub part of Windows to at least, you know, do a quick taste test to see if your change is going to break something obvious?
I don't know. I actually haven't used the Windows, like I haven't made changes to the compiler itself very much.
Right.
And Windows doesn't ingest, doesn't ingest libraries every change that we do. So I haven't interacted with that system very much other than to hear compiler folks complain. But for the most part, we don't need that because we have like 1 million plus of our own tests that we do every commit, basically. So we have, I don't know, it only takes 20 minutes to run, but that's spread over like 100 machines. So yeah, the compiler has been building test collateral since like the mid-70s.
Wow.
Yeah.
Like you find tests with like Dave Cutler's initials on them. Dave Cutler is the guy who designed NT, designed the kernel.
Oh, wow.
And there's a book during that process of the development of NT that's like really well written and at one time was hugely popular. I can't remember the name of it now.
You can look that up.
I'm going to attempt to look it up, but we don't have to stop the conversation.
Maybe I'll have to read something like that then.
Yeah.
It's like I know who the guy is just because, you know, there's only one senior technical fellow at the company.
Is he still there then?
Yes. Yeah, he works in Azure stuff now, I think.
That's cool. The book was Showstopper, The Breakneck Race to Create Windows Int T and the Next Generation at Microsoft, 1994. If you want a copy of it today, it's $85 because it's out of print.
Okay. Well, Billy, why don't you tell us a little bit more about how you got started with C++? Obviously, we went over a little bit of your bio.
Well, it was really like middle high school era, and I did volunteer work on these internet forums, like Bleeping Computer was one of them, and there were a whole bunch of others, where at the time Windows didn't come with antivirus software. And so there were lots of users who would get, they would install their 50 free screensavers from whatever website they had visited. And they would get their 50 free screensavers and malicious software. And we had tools that would like list all of the auto start places in Windows and like files that were modified recently and stuff like this. And then we'd dump that into a report. And then the user would paste that report into a forum post, and then we would read that and go, oh, that is 8 random characters.dll in your auto start entry. That's probably bad. And then we would write a little script that would delete that thing.
It was all just for fun of it, volunteer stuff?
Yeah, something like that. And I wanted to write tools that this community would use. And because of that environment, you need single binary, like here's the exe and that's it, deployment. Because machines that are broken because they are full of viruses tend to not like running installers and that sort of thing. So if you wanted that at the time, the only game in town was C++. So that's how I started looking at that, and I saw like Stefan's Channel 9 talks. This would have been 2006-ish or 2009-ish. That about 10 years ago, I guess. And then right after that, I did a whole bunch of Stack Overflow question answering and met James McNellis from that community. And well, Stefan and James, back in 2015 when I joined the C++ team, were on the C++ team. So James was the C runtime maintainer and Stefan was the STL maintainer. And so when the security team that I used to be part of got, let's say, downsized when they removed the Trustworthy Computing org, I asked to interview with them, and they thought I was useful in some capacity, I guess.
That's cool. So you did this work, debugging people's computers effectively, devirusing them. I would say it's largely manual, automatic. It's like an automated manual process.
Well, at the time it was, but for the most part, it's. I mean, I haven't actually worked on like a antivirus engine, but I'm pretty sure that nowadays what they were doing would, like something like Defender would just stop that.
Right.
And like the bad, like right around the time when I left that community, the really bad things had started to do things like hijacking your master boot record to hide themselves. That stuff becomes more, you need a tool written by some antivirus vendor.
Right.
And tell the user to run it and hope it works. It's a lot less, just find the starting random DLL names in your auto start list.
But that kind of hobby work directly led to your job then, since you're at the security team?
Yes. When I, for example, when they interviewed me to be an intern to work on that security team, they asked me if I knew how the stack protector worked. And I just said canaries, and they were like, "Okay, that's better than like every other intern we've interviewed." I'm like, "I don't know the specific assembly, but I know that, make sure the thing before the return address hasn't been overwritten, sort of thing." And I think as an intern, I did a static analysis tool that they threw away. Well, I mean, because what that team does is, or did, I should say, they took stuff that came out of Microsoft research, like, let's say Blaster comes out, or one of the big, this is a vulnerability that's in the news. And they would write a tool, and the question would be, okay, well, we're Microsoft, and we have, umpteen millions of lines of code. Can we find all of the places that are just like this exploit we just fixed? And so research would write a thing that would be better than nothing. Right. Like, it would have a ridiculous false positive rate, but, it's still faster than audit millions of lines of code for this pattern. And what my previous team did is they took that thing that barely worked that came out of research and tried to make it good enough that we could make it a release gate.
Okay.
So, like, you do not ship Windows while this tool says you have, for example, potentially uninitialized pointer. Like, there's a list of compiler warnings, for example, and then there's a tool that makes sure that you didn't turn off those compiler warnings in the compiler.
I feel like a lot of projects I work on need a similar tool.
Yeah, in fact, the current incarnation of that is called BinSkim, and it's on GitHub. It cracks open your PDBs and makes sure there are no compiler command lines with warning disable specific warning, because they don't want to ban. Yes.
Okay. We'll put a link to that because I have to know that exists. I have to know all about all the tools. Excuse me.
Yes. Yeah, and it's not like you can't suppress this warning ever. We don't want you to suppress the warning on a project-wide level sort of thing.
Sounds
neat.
Yes.
So how long did you do that?
Well, I graduated 2012, so I was an intern the previous summer. So if you count the internship, that would have been from 2011 to 2015-ish,
Okay.
So 4 years. Wow, that means I've been on the C++ team for as long as I was on that team. That's interesting to think about. Anyway, yes. So something like that.
I'm always fascinated by these stories where someone's personal interest or hobby or whatever kind of directly led to what they got paid to do, at least for some amount of time. So
Yes.
Thank you.
Yeah, the libraries team are workaholics, and probably not in a good way, but that's that's why all of us are crazy people. It's fine.
Okay.
So you joined the MSVC library team, I guess, at a pretty exciting time because they were, working a lot harder on conformance. What were some of the first things you worked on when you joined?
So the first thing I worked on, the first thing I remember working on, let's go with that.
Sure.
There was a bug in our regex engine where it was if you had all spaces star, all things that are not spaces star, that whole quantity starred. So it's just a really long way of saying anything.
Right. Okay.
Our regex engine really didn't like when you did that. It still really doesn't like when you do that, but at least I made it not emit wrong answers. And so I spent weeks debugging this thing, or I don't know, maybe a week debugging this thing, and I wrote a thing that would dump out the DFA that the regex parser spat out so that I had some idea of what it was doing. And it turned out the reason I remember this is the exact line that had the failure, and the exact failure was caught by the compiler, but the regex engine that we had licensed had a thing where they put the function local into a local static and then just immediately read it out of the local static, and there was a comment next to it, to quiet diagnostics. You remove that, and the compiler was like, here's the bug. It was like a char out of range thing. Yeah, so needless to say, right after that, I went and found all of the to quiet diagnostics comments in the code base and removed those.
Wow. That's just a really important lesson. I don't know how many times that I've interacted with people that are like, oh, well, I tried turning on that warning, but it was just far too noisy, so I turned it back off again.
I mean,
there's a reason.
Static analysis warnings can be very noisy. Like that's why we tell people not to use wall in our compiler, because wall for us is equivalent to like GCC or Clang W everything, and includes warnings like this behavior changed since Visual C++ 6. Like, I mean, people want to be able to audit their code base for that, but that doesn't mean it makes sense to turn on all the time. But yeah, like compiler diagnostic, like the ones that make it into like W extra or our W4, they go there because they find substantial numbers of bugs, and I don't know how the other standard library maintainers live with their treating the standard library as a system header.
Okay,
thing.
Let's go ahead and talk about that, because that is one of my personal pet peeves. So go ahead and explain what you just said. For the sake of our listeners.
Sure. So the other standard libraries, libstd C++ and libc++, which are the standard libraries for GCC and Clang, respectively, operate in this world where they use this GCC feature called system headers that Clang presumably implemented for GCC compatibility, where if the header doesn't come from, the idea is if the header doesn't come from your project, you don't get warnings for it because, well, presumably you can't do anything about it. It's a header that came with your system. Like if unistud.h or windows.h has a warning in it, what are you supposed to do about that?
Right.
We don't do that, or our standard library doesn't do that, because the standard library is full of templates. So you can convince the standard library to do things on your behalf, and you should get warnings for those because they're your fault. So, for example, if you assign a 64-bit unsigned number into an int, the compiler will emit a warning saying, this is a possibly narrowing conversion. You probably didn't want to do that, or you probably at least wanted to check what you were doing.
Right.
If you get std transform to do that same assignment, by giving it a transform that returns a big unsigned int and assigning it into an int range, that's still you writing the same code. And so our view is that you should get that warning.
Right.
And that means that our headers, we assume, have all of the warnings turned on, or most of the warnings turned on. If you look at our sources that we just shipped on GitHub, in September, and you look at our tests, we run it with W4 and like a list of the warnings from WAL that people have argued for us to turn on. And we do have some like library-wide suppressions, like unfortunately the unreachable code warning is a very good warning to find vulnerabilities, but in templates it's difficult to use correctly. So like we have that one suppressed in the headers.
Okay.
But we do that on a case-by-case basis. We don't just say, this isn't a standard library header, therefore no warning, because then those cases like transform or for each, where the user wrote the thing that's being warned about effectively, that they deserve to get that notification. So you said this was your pet peeve. What? My
pet peeve is the standard libraries that exclude themselves.
Oh, I see.
Because the number of warnings that are missed. So I'm fully on the Microsoft team when it comes to this.
I see.
I wasn't trying to give you a hard time. I wanted you to explain why it's important.
Well, I do, we do occasionally miss things.
Right.
And I do understand users who are angry, like, I can't turn on this warning in my code base because you have a mistake over here. Standard library maintainers, what are you doing? I don't know, for a long time, random, for example, was full of, if you make the random distribution for float instead of for double, well, the core language rules for promotions really want everything to be double.
Right.
And we didn't have all of the casts. Like when you touch user types that can be smaller than int or double for integers or floating point respectively, you need to cast like everything back to the original type, because like char plus char is int,
Yeah. That one has caught me several times in code as well, and I'm like, okay, I'm tired of the static casts that I have to write now. But you have to, and I've learned in my code that without those static casts there, I actually did have some actual bugs in the code where I was doing promotion that could lead to an actual incorrect answer in some cases.
Yes. I saw people complaining like, GCC's warning for this complains about like char plus equals int. It's like, well, that's because plus equals is form the int result and then assign it over the char again, which doesn't do what people expect a lot of the time.
And the only way to do that without a warning is char equals static cast char plus int or whatever.
Yes, you have to calculate the result and then explicitly, like, it doesn't give you the correct result that you expected, but it at least makes it explicit what it's doing, if that makes sense.
Yeah, because if there's overflow, and there's,
Well, it's because everything promotes first. Like, you can't, like, if I recall correctly, you can't even calculate, like, char plus char, because both of the parameters get promoted to int first.
Perhaps. That I'm not positive about.
But the usual arithmetic conversions are. I'm sure they were a good idea in the 70s.
So over the past 5 years, what are some of the more interesting or challenging parts you've worked on in the standard library?
A lot of it is that it's not like standard library code authoring stuff. It's taking proposals that come out of the committee where, not to fault the committee or anybody on the committee, but big chunks of it come from like the Linux HPC world. So like the committee has a lot of people who work at the U.S. Department of Energy labs, for example. Mm-hmm. Like these are the folks who program like Summit, the biggest supercomputer in the world, to do things. And so their model is we own the whole machine. We have a zillion cores on this box, and we own the box while we're running on it, and we don't need to worry. Like, we assume we can take over the system, and as long as we get our workload done faster, that's a win. Whereas we don't target Linux or a POSIX environment, and we are more concerned with like health of the system. So like burn all of the CPU cores to get this done 5% faster is a win for the HPC guys and is a loss for us. Mm-hmm. And also there are things like Windows dynamic linking model is different than POSIX. So if you notice, if you look at stdatomic for not lock-free things, so you can make stdatomic of, 200 byte struct.
Right.
For example. No CPU in the world has a 200-byte atomic instruction.
Okay.
So you're going to touch the non-lock-free atomics. We put the lock for the non-lock-free atomics in the atomic itself. And the other standard libraries have this like external lock table thing.
Okay.
So because you will only need as many locks as you have threads. Okay. On average. Mm-hmm. Like they have like a hash table of locks that then use like the address of the atomic as as the key into the table. And they're only holding the lock for as long to do the memcopy or memcomp of the type in the atomic.
Okay.
So it's more space efficient to have the external table, especially because a lot of these things often have large alignment requirements. Like if you put an align as 200 thing in that atomic, the fact that we stick one extra byte for the lock doubles the size of the atomic on you.
Okay.
So there are good reasons to move it out. But the problem is that in Windows's linking model, and it's going to sound like I'm ripping on Windows's linking model. They're ABI reasons and stuff that I like Windows' model for, but this is one of the consequences is a typical Windows program has like 4 standard libraries in it.
Okay.
Right? Like Windows has theirs, and they don't want like their use of strtoke to stomp on the user's use of strtoke,
Okay.
for example. And so in Windows model, every symbol is like namespaced to the module it comes from. So it's not strtoke, it's UCRT based ! Strtoke.
Okay.
So it's difficult for us to use that external lock table model because we want you to be able to pass like pointers to atomics around between modules and that just work. Whereas if we used an external lock table, if the pointer to the atomic was passed around like between 2 different DLLs that statically link the standard library, they would be using different lock tables, which means it wouldn't be atomic anymore.
Right.
And whereas in the POSIX model, they have a process-wide symbol table, and so you can have as many copies of the standard library as you want because the operating system loader in that environment will just pick one. So you don't have this multiple people want to provide the same facility problem. Of course, the advantage of the Windows model is you can have different modules that use different standard libraries, and that works. You don't have this ABI, like, if people disagree on what the layout of string is, it causes a problem. It doesn't really cause a problem on Windows as long as they don't put that in their interface, in their exported interface, if that makes any sense. So your original question was, sorry, I went on this little rant. Your original question was, what is the what is the challenging thing? It's explaining to people who aren't from this world, like why their thing that seems so obvious to them can't work for you.
Right.
And things like this external lock table is one of them. Like recently there was a proposal for RCU that went through the concurrency and parallelism group. RCU is a like pseudo garbage collection thing that solves block-free programming problems.
Okay.
And they wanted the standard library to like create a thread whose job it is to reclaim the memory for the RCU. And I'm like, well, I can't do that. I if somebody loads the standard library into a shell extension and then unloads the shell extension, I can't have any threads that are still running, because then you unload the code, the thread is running, and that tends to not be good for the program.
Right. Huh. That's interesting. How often does that?
Yeah.
How often does it come up when there's something like that where you're like, well, actually, that's not possible on whatever?
It doesn't come up super often, but I mean, I think I see it more than some of my coworkers, just because most of the things that I've touched in the standard library have been the concurrency things. And most of the things the rest of the committee proposes don't have this like deep platform integration impact. Like Vector doesn't care about this problem.
Right.
Like, Format doesn't care about this problem. Like only really the concurrency stuff does, and that's because the concurrency stuff has this non-composition problem. Like if you have 2 libraries that want to maintain thread pools, and you try to use them together, the result is not usually good.
Okay.
Like you can create deadlocks where one of them is waiting, like the thread pools are waiting on each other and nobody can create new threads, for example. And so a lot of the things SG1 wants to do really are, like, they have to be program global for them to work. And in this, well, we don't agree on what standard library we're using world. That's difficult.
I think I'm a huge fan of cross-platform code. Like everything that I work on, I try to make it cross-platform, multi-platform. And I feel like these differences that you're describing, some people might be listening to it and go, well, that's stupid. Windows should just use the model that everyone else uses. I'm sitting here going, this is hugely important that we don't have the entire computing world doing the same thing. And instead, we understand a larger picture and different issues.
I'm not sure. I think the systems that we have ended up with are sort of products of the world they're intended to target. So,
Okay.
like, POSIX world, for the most part, it's assumed that you distribute things as source code. Maybe I'm overgeneralizing here, but like,
Yeah.
it's expected that you can just rebuild your program to some extent. Whereas Windows has always been a very binary deployment environment. Like, we talk to customers and they're like, we're so happy that Visual C++ is finally conforming. Now the bottleneck is GCC, some ridiculous old version, because that's what's bundled on some distro we have to support.
Right.
Right. So, I mean, so the consequence is on the POSIX implementations, they get better code sharing. It's easier to share like templated code between people. But like, that's why we can run our new shiny standard library on Vista that shipped in 2006, and trying to run modern code on a 2006 Linux distro would be interesting.
That's a good point.
But like, there are consequences of that are surprising. Like, people don't expect putting a local static in a header to give you one local static per DLL that included the header.
Right.
And I've heard people tell me that that's broken. And, well, maybe, but that's like firewalling things within the individual who's deploying that thing is the only way to ensure that you can cleanly swap out modules without worrying about API explosions. Like, that's one of the reasons why the committee recently has had this ABI problem, because in POSIX world, only one person or only one entity gets to say what vector : vector does.
Mm-hmm.
Since you mentioned it, do you have any opinions you wanted to share about the ABI discussions that have been ongoing in the committee?
So it's, we still have lots of customers. We've been ABI stabilized since VS 2015.
Mm-hmm.
That was kind of actually sprung on us. Like, we got asked to do that, and we said, okay, we need to do all of these things to make that better. And then we got told, well, no, like, people need this now. So it was very. So anyway, but like, we have more ABI lock-in problems than the other implementations do because we allow people to deploy the libraries themselves. So like, we are obligated to break ABI occasionally because we have to do it even to add stuff. So like, we can't add new exports from our own library because somebody could have already deployed an older copy of the library next to their exe. So the operating system loader picks that one.
Right.
And
Okay.
so if you deployed something that needs to be one of these guest in somebody else's process scenarios, like a shell extension or a print driver or whatever, the user will go to print and the process will crash because these new exports that you're looking for are not present in the version of the library that's loaded. And we've been able to work around this by adding like more DLLs. That's why when you deploy our library, like, we have a DLL that only contains the default memory resource variable, and that's it.
Wow. Okay.
Huh.
And so for some things, we're able to add more libraries to work around the problem, but like, eventually there will be things where they need to interact with other things that are already in the separately compiled library, and then we're stuck. We have to rename the DLL to something else, and that's an ABI rig. So in a sense, we need to do it more often than the other vendors might need to do because we let users deploy that. So we care about ABI and that we don't want to do it gratuitously. I don't know. I think we propose something like every 5 or 10 years we should just do that.
Mm-hmm.
But like it's easier for us as well because of that whole DLL scenario. Like you can have one program with 2 components compiled with different standard libraries in them and it's fine. Whereas on the POSIX implementations, I don't know how they would solve that problem because both standard libraries would want the same symbol names.
You pick whichever one is linked first.
Right, but like the operating system loader does that.
Yes. Yeah, you don't really necessarily have a way to control it. That's
right. So
yeah.
If you have, in the POSIX world, if you have a print driver that wanted standard library version 1234 and its stood string layout is this.
Yeah. Too bad.
Yeah, like you're toast. There's no saving that. And that's why on lots of Linux distros, your only options are GCC and libs to C++ and, outside of toy examples.
Makes sense.
Yeah.
So I'm actually, to go back, if you don't mind, a little bit to your standard library work. You were involved in, do I remember correctly that you were involved in the implementation of the parallel STL algorithms?
Yes, that was an interesting, like when that paper went in, there were like 8 supposed implementations of this thing. And we were surprised to find that supposedly one of them was ours. Anyway, yeah, so I think the Intel's TBB implementation was the first one of those that shipped, and then we went right after them. And that's another example of this. We care about things that maybe the HPC community doesn't care about. Like with us, you can call parallel sort, and as soon as parallel sort returns, unload the standard library.
Okay.
Which means that we don't have thread pools inside the standard library itself. Like literally when you call parallel sort, we spin up a whole work stealing scheduler just to do sort.
Wow. Okay.
And then tear it all down before we return. And surprisingly, that performed very well in testing. So, hooray. Whereas, Thrust would, for example, is NVIDIA's implementation of the same. They're targeting a GPU. We wanted to limit the damage of calling parallel anything with bad sizes. So, for example, if you wanted to parallel sort 6 elements,
right,
or for each 6 elements, if you do this on Thrust, well, they're going to do this copy the memory to the GPU operation, and then sort the 6 elements on the GPU, and then copy the result back. And so, the consequence of doing that when n is too small and parallelism doesn't win can be relatively expensive.
Right.
Whereas we assume that most of the time n is small. And so we take steps to make we gave up some percentage of maximum theoretical performance with n being huge in order to limit the damage when n is small.
Okay.
If that makes any sense.
Yeah. We had on here, I don't remember who it was, someone a long time ago, and we were first talking about the parallel STL. If I recall correctly, he suggested that in the future, when we all have the parallel algorithms, that we should just specify, is it sequential or whatever? I forget what the 3 are.
It's
parallel,
seek, par, and par on seek.
That you should specify that as appropriate for your data every single time you call an algorithm, and let the standard library decide if it should be doing anything different with it.
Right, and that's why we were so paranoid about making sure that the result when n was small was not too bad.
Right.
Mm-hmm.
So would you suggest that, or if I as the programmer know that this thing is never more than 10 elements, should I pass those flags, or should I just say, no, just use this normal sort?
I would say profile,
Okay.
because, I mean, how do I put this? There are some cases where you might be able to avoid profiling. So like a general rule of thumb is if the algorithm has to do more than order of n work, it's probably a good idea to parallelize. So like the crossover point for sort was, I think, like sort ints was like 1,000 elements.
Okay.
When I tested, and like lots of programs sort more than 1,000 elements.
Sure.
Whereas for something like for each or transform reduce, n has to be quite large before the parallel version wins, because the instant you involve another thread, you have to like cross caches onto another core.
Hmm.
So like if all of the data you're working with was on the local cache on your core, then parallelism will lose. But that depends on what your data looks like, and so it's hard to give you like a hard and fast
Sure.
Right.
this rule. And I think, I don't know, there seems to be a thought that the standard library can do more than it really can on some of these things. Like I've had people say that they expect parallel copy to somehow discover which NUMA nodes the memory that are input to copy come from, and
That
like
sounds unlikely.
and like parallelize appropriately to that, like do the right NUMA node copying. And yeah, I that was my response. Like, how do you expect std copy to figure that out? So I don't know. Like given the fact that this thing, like there are a lot of promises of the parallel algorithms library, but I haven't seen anybody like actually implement this idea of the compiler can do something smart about parallelizing this.
Right.
I'm not saying it's impossible, but it's certainly a useful tool.
Mm-hmm.
Mm-hmm.
But it's I would expect people to assume like it's library tech. It's like we're going to spawn some number of threads and call your callbacks on them. Not like reach into your callback and see that you're calling another parallel algorithm inside and that sort of thing. So I'm not sure if I answered your question.
Sure.
Like I guess maybe I don't know how to answer your question.
No, that's fine. You gave a lot of information. Yeah. I'm still kind of waiting to use the parallel algorithms because I haven't tried them on Visual Studio yet. And let's be fair, that's the only implementation that we actually have in our standard.
Doesn't GCC 10 have it?
Yes, but you have to link to a separate library, which I think is the TBB from Intel.
I see. Okay.
So yes, now I could also, as of very recently. No, actually GCC 10's not even out yet, technically. So theoretically, very soon, I will be able to.
I would be interested to hear if they ended up fixing the forward progress problem with TBB. Like one of the rules in the standard, in the spec for these, is that the parallel algorithms library is not supposed to be able to introduce deadlocks into your program. So like
that sounds reasonable, yeah.
Sounds
reasonable.
You say that, but a lot of parallelism frameworks like assume when you give them work that their thread pool will have a thread available.
Okay.
Which is a reasonable assumption for a lot of the time.
So what, I would have to try to create a thread, and if it can't, then go back to doing the work in the current thread?
Right. So what we do is we use the current thread to help. Like we go to the system thread pool, which is create thread pool work, submit thread pool work, wait for thread pool work callbacks. Like those are Win32 APIs. Right. And so we go to the thread pool and we say, here's some work. Can you please help us? And then we just start doing the work. And if the thread pool doesn't get to it before we're done, we yank the work off of the thread pool and say, nope, sorry, we didn't want that. That's fine. And that's super important for handling that small n case I was talking about, because quite often if n is like 100, like one context switch is more than it takes to do all of that processing. So you never get a thread pool thread, even if there are thread pool threads available, because you're already done.
Right.
And I don't know if they ever actually implemented the forward progress guarantee stuff. I know they had issues once upon a time. But now it sounds like I'm bad-mouthing another implementation that I haven't seen, so maybe I should. I don't intend to say that.
So.
That's, yeah.
Like maybe they do have this implemented somehow. I don't know.
So we've talked a lot about different standard library work you've done, but you did mention in your bio how you are sometimes on loan. I think you're currently doing work with the VC package team. Do you want to tell us a little bit about what you've done there?
Yes. So we just had a blog post a couple days ago about. So for those who aren't familiar, vcpkg is it's a tool that downloads source code and builds it for a whole bunch of open source libraries, that sort of thing. Mm-hmm. And there are things that have been put into the standard library, like say regex, that we think have been kind of mistakes. Like all of the regex implementations in the three major standard libraries are bad. Like lose by hundreds of times to regex engines like Google's RE2.
Right. Mm-hmm. Or PCRE
Yeah. And that's because the people who wrote those regex engines are people who eat text processing for breakfast and are geniuses, and the people who wrote the standard regex engines are standard library maintainers. And I don't want to denigrate standard library maintainers, of course, but like we touch regex today and touch atomic and parallel algorithms tomorrow and file system the next day. Like we're not specialized at anything. And so that's, if one of the implementations was bad, then I could go, okay, well maybe those guys didn't know what they were doing. But like all three of them are bad suggests a problem. So anyway, we want to be able to tell people, just go vcpkg install RE2. Like mm-hmm. things that don't need this ABI stabilized, like there's no argument that programs need a regex engine, for example. But the argument is, well, does that really belong in STUD if we have a tool available, or if we have tooling available on all of the major platforms where you can just go grab a thing that does that thing? Like, it only needs to be in STUD if everybody needs to agree exactly on what its interface and layout are. So anyway, we're trying to today when you use vcpkg, you actually build the tool itself. Like you call bootstrap vcpkg and it builds itself using whatever compiler you have locally. And we've had people who don't like to do that. Like they want to have a binary so that they're not building it every time. So that's kind of what I've been doing for the vcpkg team recently. It's like get that team ready to do code signing, go through all of the security policies and legal stuff, right? Because when you're, in top 10 most valuable companies, people like to go after you for things that they wouldn't go after, let's say, other vendors for.
Right.
So, and also, it would be bad setting up that infrastructure for them because, for example, today we build, when you submit a package to vcpkg for inclusion in the catalog, we build it. Well, if your package is, I'm going to try to steal the Microsoft signing key package,
right?
It turns out there are lots of people that would love to have Microsoft signing keys.
Fascinating.
Yes, like some of the malware vendors that we started this conversation about, for example. So, we need to do things like never build the user code on the machines that can sign.
Okay.
That sort of thing. And yeah, setting that all that's what I've been doing for the last couple of months for them. And also onboarding them to this preview Azure Pipelines scale sets feature. So previously, because building the whole catalog takes 9 hours, but building most submissions only takes 5 minutes.
Okay. Mm-hmm.
So they had 12 machines always on in Azure, which tends to be kind of expensive. Whereas the Azure Pipelines team just came out with this thing where it will automatically scale. Like, oh, I'm seeing more pull requests on GitHub come in. Go fire up some more machines.
Okay.
Nice.
So I'm kind of curious about your opinion on this now. Well, I am curious, so I'm going to ask. Say I'm kind of curious is weird. Anyhow, every project, now I don't want to discuss Conan versus VC package or anything like that, but every project that I'm involved in right now has Conan. It has a package manager, more to the point. So based on what you just said a moment ago, do you see, like, hypothetically a decreasing role for the standard library as more people are using package managers?
I think that's what we would like to see, yes.
Okay.
Right,
and by
because...
we, do you mean like the royal we, or do you mean the standard committee, or...
So I don't know if that's a universally held opinion of the C++ team, but many people on the C++ team have that opinion because like a lot of the stuff that I just talked about, like the unload problem or the be a guest in somebody else's process problem, like those aren't problems for everyone, right? Like the advantage of putting it in std is it's available everywhere. The corollary to that is everything we put in std has to be able to go everywhere.
Right.
And that means there's useful stuff that we're leaving on the floor and that we must leave on the floor for std to achieve its mission of being universally available. So something like thrusts, which is a let's go target GPUs with stuff library, undeniably does something useful, but I don't think we could ever put it into std.
Right.
Because we can't assume that you have an NVIDIA GPU.
Right.
Okay. Yeah.
That sort of thing. And there are lots of software ecosystems in the world that have small standard libraries, relatively speaking, and package managers to fill in the gaps. Like NPM for Node.js is a classic example. Rust has Crate. And so, sure, they don't have a web server in their standard library, but who cares? They have libraries readily available that do.
Right.
It's interesting getting your opinion as both STL maintainer and someone who's worked on a package manager that you're definitely very pro package manager.
Yes. Yeah, like I said, I don't know if that opinion is universal on the team. I haven't done that polling, but
that's fine. Yeah.
Yeah. Okay. Well, Billy, it's been great having you on the show today.
Thanks.
Yeah, that was good. Thank you very much.
It's been a great experience.
Yeah.